this video, we're going to do some examples of improper integrals that have infinite limits of integration. So in this orange box at the top, we have our three cases that we could have for these. So the first case is you are taking the you're taking the integral from some number to infinity. And your first step is going to be to change it to a limit, and you can choose any letter. We choose B here. Limit as B goes to infinity, and now you're taking the integral from A to B, because we can't integrate from some number to infinity technically, but we can do a limit. Your second case is you are taking the integral from negative infinity to some number B. First step is you're going to use a limit. Again, choose some letter. So we're saying A. Limit as A goes to negative infinity. And now we're taking the definite integral from A to B of f of x dx. Third case is you have negative infinity to infinity in your integral. For this case, you're going to start by splitting your integral into two separate integrals. You're going to choose some letter C to use to split it up. Choose something easy like a 0 or a 1. And then from there, you're going to have both case 1 and case 2 in your problem. So we're going to do one example of each of these types. Now we do say at the end, if the limit exists, we say that the integral converges. And if the limit does not exist, then the integral diverges. So we'll talk about that as well. So let's do a couple of examples. Starting with number 1, notice that you have your infinity as one of your bounds of your integral. Again, we don't want an infinity, we want a number. So first step is I'm going to take a limit as some number b goes to that infinity. And now my bounds of my integral are 1 and b. From here, you're going to evaluate your definite integral as you normally would. And then once you are done with that, you're going to evaluate the limit. So I'm just going to carry down my limit as b goes to infinity. We're starting with a pretty simple integral. I'm going to increase my exponent by 1, so I get negative 1/2. Multiply that by that negative 2 out front. And we're doing our integral from 1 to b. Okay, keep evaluating that definite integral. I'm going to have my negative 2 out front. So now I have b to the 1/2, negative 1/2 I should say, minus 1 to the negative 1/2. All right, now let's make this a little bit simpler. This is the same thing as 1 over the square root of b minus 1 to the negative 1/2 is just 1. For our limit, I'm going to bring the negative 2 out front, in case that makes a little bit more sense for everybody. But let's evaluate this limit now. I want you to notice if b goes to infinity, 1 over rad b is going to go to 0 because that number just gets smaller and smaller and smaller. And so the limit ends up being negative 1. So I have this negative 2 out front times this negative 1. So my answer is 2. And since we get an answer here, we're going to say that the limit, or I should say the integral, converges. So your answer is 2, but we can also say on the side our integral converges. Okay, let's do another example. Okay, for this one, I'm taking the integral from 1 to infinity, so same thing. I want the limit as b goes to that infinity, and now I'm integrating from 1 to b. Same thing, we're going to evaluate our definite integral, and then we will take the limit. Okay, now the integral of 1 over x is natural log of the absolute value of x. and this is from 1 to b. But I want you to notice 1 to b, that's all positive numbers, so you really don't need your absolute value, so I'm going to take that out. So now I have the limit as b goes to infinity of the natural log of b minus the natural log of 1. Let's do our limit. Keep in mind that our graph of natural log looks like this. So if I take the limit as b goes to infinity, as this goes to infinity, natural log of b goes to infinity. So this goes to infinity. So we get infinity as our answer. These should all be equal signs. So we would say that this integral diverges. So just to give you an example of one of each type, one converges, one diverges. Let's also do an example where we have infinities on both bounds. So for this, we said you want to split this up into two separate integrals. Pick a number where you separate them. I'm going to pick 0 just because it's easy. And now it takes a little bit of work organizing, but now we have one of each of types 1 and 2 from that box on the front. So I'm going to set up my limits. I have the limit as a goes to negative infinity. Again, you can pick any letter. We just tend to pick a and b. But make sure you pick a different letter for this second one. So I'm going to say limit as b goes to positive infinity from 0 to b. Just like we did before, we're going to evaluate our definite integrals first, and then we'll worry about the limits. So the integral of 1 over 1 plus x squared is actually inverse tangent. So this is arctan of x evaluated from a to 0 plus my other limit of arctangent of x, now from 0 to b. So I'm going to plug in. I have arctangent of 0 minus arctangent of a plus my limit as b goes to infinity of arctangent of b minus arctangent of 0. Let's see if we can simplify a little bit. Let's figure out arctangent of 0. Couple ways you can think about it. First thing is you can ask yourself the tangent of what gives me 0. Keep in mind that your answer has to be between negative pi over 2 and pi over 2. Tangent of 0 gives you 0, so that means arctangent of 0 equals 0. Second thing that you can do is picture the graph of arctangent. Arctangent looks like this, and we have horizontal asymptotes, y equals negative pi over 2, and I'll write it over here, y equals pi over 2. So if this is my arctangent graph, arctangent of 0 is 0. So a couple ways to think about it, but this makes it a little bit easier for us. We have limit as a goes to negative infinity of negative arctangent of a plus the limit as b goes to infinity of arctangent of b. Okay, I'm going to pull the negative out front. It's going to make our limits a little bit nicer, and we'll deal with it after we evaluate the limits. So let's evaluate our limits. I'm going to start by bringing down the negative. And we're actually going to use our graph of arctangent. So for the first one, I want to know the limit as a goes to negative infinity of arctangent of a. So as we go to negative infinity, arctangent approaches negative pi over 2. So my first limit is negative pi over 2. As we go to infinity, arctangent goes toward positive pi over 2. So we're going to have that positive pi over 2. Simplify this, my negatives become positive pi over 2 plus pi over 2, which is pi. So my answer for this integral is pi. Because we get pi as our answer, we're going to say the integral converges. Those are a few examples of improper integrals with infinite limits of integration.